Assalamualaikum warahmatullahi wabarakatuh. I, Daniel Faris, and with my group mates, Muhammad Shahir, Nurul Fatina, and Sarah Amanda, shall present about the exponential function in investment. Now, first off, let's begin with the introduction.
The introduction of exponential function is that it's an important class of nonlinear functions that is of particular interest in economics comprised of the exponential and logarithm functions. These functions are useful for investigating problems associated with economic growth and decay and mathematical problems in finance such as the compounding of interest on an investment or the depreciation of an asset. Investment expenditures. Investment expenditures is the smallest and the least stable component of GNP. There are two categories of investment expenditures. One of is planned investment, which is anticipated or intended investment. Planned investment is the investment expenditure the business firm would like to make over a period of time based on the condition of the economy. It includes the amount of new plant, equipment, and housing acquired during the year and in addition to inventories which business want to acquire. The second is realized investment, which is actual investment. This is the investment expenditure that the business actually make over a period of time. The quantity which show up in the official national products always include all investment in plant, equipment, housing, and inventories, whether that investment is desired or not. The difference between planned investment and realized investment is called unplanned change in inventories or investment. Unplanned investment or undesired inventory accumulation are products that remain unsold. It's stocked up on retailers' shelf and in warehouse.
Investment and interest rate. Interest rate is a charge imposed for the use of borrowed funds over a period of time. It affects the cost of investment. As interest rate increase, the cost of borrowing will be higher, hence the cost of making the investment will be higher. Consequently, investment will decrease and vice versa. The relationship between interest rate and investment is negative. Interest rate is also influence business in terms of earning a higher return on the money or funds that they place in the financial market. A higher interest rate will motivate business to place their money in the bank to earn higher return, therefore discourage them from using the money in making investment purpose. A lower rate of interest will cause business to spend their money in making investment which they anticipate to give a higher return on investment compared to the low interest rate. What is compound interest? Compound interest or compounding interest is interest calculated on the initial principal and also on the accumulated interest of previous periods of a deposit or a loan. Thought to have originated in 7th century Italy, compound interest can be thought of as an interest on interest and will make a sum grow faster at a rate than simple interest, which is calculated on the principal amount. The rate of which compound interest occurs depends on the frequency of compounding. The higher the compounding number of compounding periods, the greater the compound interest. Thus, the amount of compound interest occurs on $100 compound at 10% annually will be lower than that on $100 compounded at 5% semi-annually over the same time period. Compound interest is calculated by multiplying the principal amount by 1 plus the annual interest rate raised to the number of compound periods minus 1. The total initial amount of loans is then subtracted from the resulting value. The formula for calculating compound interest is compound interest equals total amount of principal and interest in future or future value less principal amount at present or present value. Take a 3-year loan of 10,000 at an interest rate of 5% that compounds annually. What would be the amount of interest? In this case, it would be 10,000 times the product of 1 plus 0.05 to the power of 3 minus with 1, which is equal to 10,000 times 1.157625 minus 1, which is equal to 1576.25 dollar. Now, when an investment B follows an exponential growth model with a fixed rate per period, say a period of 1 year, the investment model with respect to the time is written as annual interest rate. Yearly exponential growth model, i.e. interest, is applied at a fixed percent rate at the end of each year. Bt equals to B naught times the product of 1 plus R to the power of T, where Bt is the balance at time, T, year, and B naught is the initial investment amount, and R is the decimal equivalent of the yearly percent rate. Whenever the interest or rate of growth per period is yearly, we can call that the annual rate or nominal rate. Next, compounding greater than a yearly. If n is defined as the number of periods in a year, then we define periodic compounding as Bt is equal to B naught times the product of 1 plus R over n to the power of nt, where Bt is the balance at time t, year, and B naught is the initial investment amount, and R is the decimal equivalent of the yearly percent rate. Example compounding is monthly, n is equal to 12, quarterly, n is equal to 4, daily, n is equal to 365. Continuous compounding. When the number of compounding per yearly is large, even greater than hourly, where 365 times 24 is equal to 8,760, we define this as continuous compounding. Bt equal to B naught times E to the power of RT, where Bt is the balance at time T, year, B naught is the initial investment amount, and R is the decimal equivalent of the yearly percent rate. With all these various types of compounding, one often needs to evaluate each compounding as it compares to the yearly compounding interest rate. We call this normalization the effective annual rate. The effective annual rate is found by setting the various compounding equals to each other and finding the equivalent to the yearly rate of R from 1 plus R.